Welcome everyone to episode 3 of Ask Charlie, and I think we're getting to the heart of the entire topic of brain cancer today, because today we're going to talk about research into brain cancer, why there's so little, why we haven't made that much progress in the last few decades, and how we're going to tackle the problem. So here we go, let's get straight into it. And the first question is from Karina on Facebook, and she asks, oh, bless you, Dr. Teo. Thank you, Karina, for giving people hope. Why is it so hard to find a cure for brain tumours? The second question comes from Zia on Instagram. Do you think there will ever be a cure for brain cancer? And the third question is from John on LinkedIn. My question to you is, for someone who has lived and breathed this field so intimately, do you believe there is hope in our lifetime to increase long-term survival rates for brain tumour patients? That's pretty simple, really. It's a one-sentence response, and that is that many other cancers are homogeneous, and that is that the abnormalities and the proteins seen on the surface of the cells are quite uniform, whereas for brain cancer it is typically very heterogeneous, which means that the cells are all very different. So even when we find a target with an abnormal protein, for example, surface protein, then it doesn't attack the majority of cells, it attacks the minority of cells. And hence this heterogeneity, or the fact that there's so many different cells and so many different types of cancers. They estimate that there's probably about 300 different types of cancers in one brain cancer. In other words, it's incredibly difficult to tackle because it's so all the cells are so different. I mean, there are other factors as well. There's a thing called the blood-brain barrier, BBB. And what is that? That means that, well, we believe that anthropologically, back in the olden days, the body was designed to stop toxins from going to your brain, given that the brain is the most important organ in your body. And so this barrier prevents poisons. Well, unfortunately, chemotherapy is classified as a poison to the brain. It's damaging to the brain. So the blood-brain barrier stops a lot of the agents that we use to beat cancer in other locations in the body from getting to brain cancer. That's another factor. Another factor is that brain cancer, I guess, if you want to think about it like this, is probably one of the most intelligent cancers known to mankind. It even has a system of teaching itself how to beat therapies. And it's been shown that if you present a therapeutic agent to one part of the brain cancer, there's communication between that part and another part to teach it how to resist the chemotherapy. So it's an intelligent cancer, it's incredibly well designed. It has the MDR gene, the multi-drug resistant gene, which means it can build up resistance to chemotherapies. A lot of cancers, when they grow very quickly, they outstrip their blood supply, so the cancer sort of self-limits. But brain cancer builds its own scaffolding, its own blood supply. It has a gene called the VEGF, which means that it builds blood vessels very effectively and supplies itself with oxygen and nutrients. Some cancers die when you starve them of oxygen. Brain cancer likes it. Some cancers die when you expose them to hyperbaric oxygen, in other words, too much oxygen. But brain cancer likes that as well. So it likes too little, it likes too much. It's got its own blood supply, and it develops resistance, and it teaches itself how to develop resistance. I mean, it is incredibly intelligent. So you put those things together, and that's why we found it so hard to beat brain cancer. Okay, so John, do I think there's hope for finding a cure for brain cancer? Absolutely, or I wouldn't be in the game if I didn't think so. That's a glib response, but a more detailed response is this. Look, once the human genome was mapped, I think we then made a huge leap in advances in neuroscience. You can't tell what abnormal is unless you know what normal is. So once we knew what the normal gene sequence was in a human being, we could identify all these abnormal sequences or abnormal genes. Once we know those abnormal genes, sure, it's a matter of trying to regulate them, engineer them, target them, but at least we've made the first step, and it's a huge step. So I think It's probably going to take some time. I'm hoping no more than 5 or 10 years, but it could take 20, 25 years. But I really do believe that in my lifetime, we're going to get very close to finding a cure for brain cancer. Okay, next question comes from Teresa on Facebook. Dr. Teo, when will a new treatment finally come out? Well, look, there are new treatments coming out all the time. That's what clinical trials are all about. But when will a new definitive treatment come out? Well, let me tell you a little bit about the last decade. So temozolomide is now considered a standard treatment for brain cancer. It's a chemotherapeutic agent that crosses the blood-brain barrier, and good prospective studies have shown that it does increase survival. Now, it's not by much, unfortunately, only we're talking months, but nevertheless, it is a well-known, accepted, scientifically based treatment now for brain cancer. In the last 5 years, another treatment has come out where we use electromagnetic radiation in a helmet to treat brain cancer. And again, prospective, controlled studies have shown that it does increase survival over those people who don't get the radiation. Now, unfortunately, it's only probably maximum 2 months extra life with this helmet, but nevertheless, it is now a well-recognised treatment for brain cancer. Immunotherapy, I'm sure you've heard, has been really giving us hope with many other cancers, not so much with brain cancer. But there is a drug called Avastin. I don't like it because unfortunately it's not good for people who want further surgery. But nevertheless, it is now accepted treatment for brain cancer. Some people say, and I'm one of them, that it probably doesn't have that much effect on killing cancer cells, but it certainly does improve your quality of life. It reduces swelling, and it probably does extend life as well. And that's now TGA approved for brain cancer patients. Okay, now in terms of really good treatments like that will make a huge impact on survival, not just a matter of weeks or months, you're right, we haven't found one of them yet, but we are certainly working on it. And what I'd really like people to take away from this session is that, you know, maintain your hope, because if you don't have hope, then of course it's all going to be negative and terrible, and nothing will be done. So we've got to hope that all the things that we have in the pipeline now, all the different types of therapies we have in the pipeline, one of them eventually will come out and be a definitive, good, effective treatment for brain cancer. Rightio, so the next group of questions deals with GBM. Now GBM, let me just preempt, stands for glioblastoma multiforme, which is just another name for brain cancer, which is another name for malignant glioma, grade 4. It's all the same stuff, brain cancer. Now, there are many different types of brain cancers, but by far the most common is GBM. So let's talk about GBM. Minori on LinkedIn says, if there is any positive news on brain cancer, please tell us, particularly GBM breakthroughs. Jilly on Facebook says, how's your research going into GBM? Shin on Facebook says, I support you and your team. I am aware that clinical trials for GBM are currently ongoing. Is there any hope for the patients? Carrie on Instagram says, can you share any progress from the GBM RNA sequencing study? I'd love to know how that study is progressing. Well, they're all great questions, so let's get started. Positive news on GBM specifically? Yes and no. Positive news is that there are many different trials out there at the moment. There's a lot of immunotherapy trials, for example. There are these things called checkpoint inhibitors, and again, if you take it back a couple of steps, remember it's the T cells that are part of your immune system that recognize foreign cells, that then gobble up the foreign cells and keep you healthy. Unfortunately, brain cancer secretes something that puts a brake on the T cells. Checkpoint inhibitors take the brake off and allow the T cells to do their job. So these were considered to be something quite exciting for cancers, these checkpoint inhibitors, but they didn't seem to work that well for brain cancer. However, more recent studies have shown that the timing of when you give the checkpoint inhibitors is actually quite vital. For example, it's been shown that if you give the checkpoint inhibitors before surgery, surprisingly it works a whole lot better than if you give it after surgery. And that takes us to one of our studies actually, because one of the studies that we are funding talks about the importance of timing when you give chemotherapeutic agents or any anti-cancer agents to a patient. And it could actually be related to the circadian rhythm, because we do know that with other cancers the circadian rhythm does influence the efficacy of chemotherapeutic agents. So it's all pretty exciting, that stuff. And another, I guess, group of treatments that I find quite promising is the delivery of agents to the brain. So again, we have to talk about this blood-brain barrier phenomenon. Well, you can actually break down the blood-brain barrier, and there's a new technology called focused ultrasound which has been shown to break down the blood-brain barrier. That's the first one. Another one is that if you can attach the agent, the killing agent, to some sort of vector, then that can be carried across the blood-brain barrier, and those vectors include things like nanoparticles and viruses that are very effective in getting into cells. So if we can carry the agent across the blood-brain barrier and across into the cancer using viral vectors or breaking down the blood-brain barrier, then these can be incredibly effective as well. So it's not as if we don't have agents that can kill brain cancer, we do, but getting those agents specifically to the cancer and not to the brain itself has been quite a challenge. Radiotherapy, for example, we know that if you give enough radiotherapy to brain cancer, it will kill it. That's about 10,000 rads, but the trouble is 10,000 rads will also kill the normal brain. So a lot of people have concentrated on getting the radiotherapy to be targeted to the cancer cells and to spare the normal brain by giving agents to the patient that will then concentrate the radiotherapy on the cancer, etc., etc. So look, all these things are incredibly promising. To be a little bit realistic, none of them have come into standard treatment yet, but you know, that could be just around the corner. And what I say to my patients is, look, at the moment we don't have a cure for your cancer, but new treatments are coming out every day, and the one that's going to work on your cancer might come out next week. So just stay alive for as long as you can, because essentially the answer could be just around the corner. Okay, I just want to address Shin's question specifically, and that is clinical trials. You know, over the last 20 years I've raised over $35 million for brain cancer research, and I've been really disappointed that many of the clinical trials that have come out of that money haven't unfortunately been available to Australian patients. It's crazy. You know, the Australians are the ones who are donating the money. We identify projects that possibly could work, and they're overseas projects. And if they do come to fruition, Australian patients don't benefit from it. Now that's bad. To address that, I am specifically targeting trials that will include Australian patients and be Australian-centric actually, where Australian patients will benefit the most, and that if we can then roll it out into other countries, great, but Australia first and foremost, Australian patients first and foremost. There is a trial in America called the Adaptive or Agile GBM trial, and it basically allows virtually any patient with brain cancer to be included in that trial. And then it's an iterative trial, which means that all patients get it first, and if it doesn't work, then of course we learn from the efficacy on those patients. I want that sort of trial in Australia, and part of the funds that we will raise, hopefully, with your help, will go to starting up an adaptive trial in Australia, where again, Australian patients will benefit first and foremost, and then if we can roll it out to other countries, great, but Australia first. So the final question in this segment on GBM is from Carrie, who asked, can you share any progress from the GBM RNA sequencing studies? For those of you who don't know what we funded, well, we funded a very, very smart guy at the Garvan Institute called Joseph Powell. whose expertise is single-cell RNA sequencing. So what that means in very basic terms is that we are delving deeper into the cell to find out more about its characteristics. So you can sequence DNA, you can sequence all different types of signatures in the cell, but RNA sequencing is really looking deep into the cell to find out if there's any patterns that can be identified that then of course be targeted. It is a world first study. It's going very well. We're about to write a paper on essentially the methodology of how one does single-cell RNA sequencing. And what that means is that you can analyse these in many different ways. Some of them are more effective than others, some of them are more accurate than others, and we have now, with all the work that they've done, found the most effective and accurate way of single-cell RNA sequencing. That's going to be published soon. Of course, we've gathered a lot of data, and that was the intention of this study. The intention of the study was that the more data we have on cancer, the more we can work out algorithms to treat these cancers specifically, personally, for that person's cancer. I do want to mention one thing, and that is that I find it a little bit annoying sometimes when the Australian media comes out and says that this is a world first when it isn't. And that's happened so often. You know, when I think the first awake surgery was done in Australia, they said this was a world first, and we'd been doing awake surgery, the rest of the world had been doing it for 2 decades before then. And someone else came out and said that the use of this particular type of coagulation instrument was a world first, and I'd used it 10 years before when I was in America. So let me just clarify the world first label that we've given to the single-cell RNA sequencing project. It goes like this. You know, single-cell RNA sequencing has been done for almost all the cancers, including brain cancer. There was a paper published in Nature Communication talking about RNA sequencing in a specific type of GBM called IDH wild-type GBM. The world first for us is that we have accumulated a collection of GBMs over so many years that are so different and diverse in their morphology and makeup that the world first is that we will believe that by studying single-cell RNA sequencing on this population of cells, we may be able to come up with better answers and more algorithms and more characteristics of the cancer that we can target. So the world first is I guess the heterogeneity of all the samples that we have, as opposed to just one specific type of brain cancer. So just to give you a definition of DMG, it's diffuse midline glioma. It's the name given to what was previously called the DIPG, diffuse intrinsic pontine glioma, and it was a new classification that came out by the WHO in 2016. Universally deadly, found in children mostly, sometimes in adults, and so bad that a lot of people don't even biopsy it. There's virtually no treatment. And most people, most children diagnosed with it die within 6 to 18 months of diagnosis. Okay, so the question is from Mama Anderson. DIPG, now known as DMG in children, is devastating and terminal. You're not wrong about that. What more needs to be done to help prevent this disease, and what more would you like to see happen to help families to bear witness to this deadly disease? So the first part of the question is, what needs to be done to prevent it? Well, that is a great question, Mama Anderson, because if we knew what caused DMG, of course, it's better to prevent than to treat. At this stage, we still don't know what causes it. I did talk about that in my last 2 Ask Charlie sessions. Some of the theories are things like viruses. Other theories are abnormal genes. There are all these theories as to why kids get this terrible type of brain cancer. But unfortunately, the answer is we still don't know. So to prevent, unfortunately, we can't at this stage without knowing what causes it. The next part of your question is, how are we going to help families who have to bear witness to this deadly disease? The Charlie Teo Foundation was set up to fund research into brain cancer, not to help families. We believe we help families by giving them hope and showing that the community as a whole is behind them, and helping raise money, which then of course helps research. But in terms of giving monetary or financial assistance, or even emotional assistance to families who have gone through this terrible disease, there are many other great charities that do that, but we felt that it was better to focus on trying to find treatments for the disease rather than giving emotional support to the families. So I'm sorry about that. It's a great question, and we'd love to have the funds to do that as well, but at this stage we're concentrating all our funds on finding treatments and possibly a cure for brain cancer. So Mama Anderson, great questions. I hope I've answered them. I do want to also underscore the fact that we have concentrated on brain cancer in children as well, and this particular disease, because it is so devastating. Our aim at the Charlie Teo Foundation is to offer hope to those families that others care, and that we are working desperately hard on trying to find treatments and cure for DIPG, otherwise known as DMG. I'd like to just mention briefly two projects that we're funding. One is we're funding a brilliant scientist called Matt Dunn up at the University of Newcastle, who had his own personal story with DMG. And he's doing some pretty great work on immunotherapy and how it may impact this disease. And the other project we're funding is really very novel. It's out of Missouri in the United States, and it's using two different vectors to try and get agents into the brainstem to treat this terrible disease. One of them is to actually deliver the agent through the nose, where it doesn't have to cross the blood-brain barrier. And the other agent is the fact that they're breaking down the blood-brain barrier or any potential barriers using focused ultrasound. And the third one, they're also carrying the agent across the cells using nanoparticles. So it's a very, very concerted, multimodality targeting of this particular type of childhood cancer. So that brings us to the next big question, that is, why is brain cancer research so underfunded? And it really is. Okay, so I get asked this question all the time, because once people are aware of the impact of brain cancer, you would think that it should have the most funding of all the cancers. Okay, firstly, it is the deadliest of all the cancers, so that's bad. Secondly, it is ranked #1 in PYL's or socio-economic impact on society. So even though it's not a common cancer, it is bad enough that it has more financial, socio-emotional impact on society than any other cancer. Why? It's because it takes people out when they're very young. It often affects people in the prime of their lives. And at this stage we have no cure. So it also kills more children. Now remember, what's our future? Our future is our children. They're the ones that hold the destiny of this earth and our species in their hands. So you would think that a cancer that kills more children than any other cancer, in fact kills more children than any other disease, should get the most funding out of all cancers. You're right, it actually gets the least amount of funding. So there is a real disconnect between the impact of this cancer on society versus the funding. Why is it? It's a great question. So here's my take on it. I think it's because a lot of people adopt a nihilistic approach, and that is a very pessimistic, fatalistic approach. It's almost like, everyone dies, there's no cure, so why would we fund it? But I hope you can see that that is a self-fulfilling prophecy, that if you believe that there's never going to be a cure and therefore you shouldn't be funded, then of course there'll never be a cure. That's one reason, this nihilism or pessimism is surrounding it. The next one is that many other cancers have advocates who have survived the cancers. Breast cancer has Olivia Newton-John. Hodgkin's has Delta Goodrem. And these people go out and spread the word, as they should, that more research needs to be done into their disease. Some high-profile people have had brain cancer. Senator Ted Kennedy is just one of them. Stan Zemanek is another one. But the trouble is, that they die from their disease and they never become advocates. They are fighting the disease with all their might and all their emotional strength, and so during that fight it's very hard for them to go out and beat the drum and be advocates. The people who beat the drum and are advocates are the ones who have been cured of their cancer, and we haven't got any of them. So no high-profile advocates. Okay, another reason why it's underfunded is because, I hate to say this because I'm sure there's a lot of government officials listening, but it's true, and that is that we are very dependent on government funding. And unfortunately, governments are very dependent on popularity and staying in office. How do they stay in office? Well, they fund cancers that it's very popular to fund them, and they get votes from it. Brain cancer is not even ranked in the top 10 cancers in terms of incidence, so it's rare. And so to fund brain cancer, you're not going to get as many votes as when you fund a very, very common cancer. And I know that's going to offend a lot of people, but that's a simple fact. If more people were dying from brain cancer, and if it was affecting a high percentage of people in the population, then of course it would become a political issue and it would get political funding. It gets very, very little government funding. So therefore, grassroots charities like our charity, for example, are the ones that have to beat the drum and raise the money, rather than government. Look, there are many other different reasons as to why it's so underfunded, but they're the major reasons why I think brain cancer is underfunded. So the last big segment is how can one help? Ladies Like to Lunch Fundraising, great group of ladies on Instagram, said, what more can Australians do to help find a cure for brain cancer, as too many of these victims have lost their battle to a horrible condition? And John on LinkedIn, again, very simple, what can we do to help? So a lot of people ask this question, good-hearted people, and it goes like this. I think there are 3 things you can do. First, start the conversation. And I really think this is important. Once we get the facts out there, you would have to be almost emotionless not to help. If you knew that brain cancer kills more children in Australia than any other cancer, in fact any other disease, then surely that of itself would provoke you to do something. Furthermore, it kills more young adults than any other cancer in Australia. And then of course I did mention the fact that it has a huge impact on our society as well. So if people knew that, and I mean getting the word out there, dinner conversations, social media, hashtags, whatever you have to do, if you get that information out there, I think people will climb on board and help us try and find a cure for this terrible disease. So the next one is to donate, and I would encourage you to identify a charity that resonates with you and donate generously. Hopefully that charity is the Charlie Teo Foundation, but really I would endorse all charities that raise money for brain cancer. They're all good people doing good things. Why do I think we stand out? Well, simply because we are very, very transparent in how much money we raise, how much money we spend, and the projects that we spend it on. We are very transparent about projects that might fail, for example, because I think we can learn just as much from those that failed as those that succeed. And I've pledged to my donors that I'm going to keep my overheads very, very low. Currently we are running less than 25%. Unfortunately it does fluctuate between very low, less than 10%, and low, less than 20%, but nevertheless we are very transparent about where the money goes, and we run very, very lean using volunteerism. We don't do any cost allocations that make our numbers look more favourable. And what I mean by that is that some charities put their employees' salaries under the heading of research or raising awareness, and I don't think that's right. It's almost like it's almost like it's trying to fool people into thinking that their costs are low when they really aren't. So we are incredibly transparent about where our costs go. We don't include salaries in those topics. Those salaries are actually part of the administration costs. Okay, I'd also like to point out that, a lot of people think, well, what difference will I make? But if everyone thinks that, no one will make a difference. So I think all individuals can make a difference. We received, I think about $16 on average a week from a group of ladies who would take the small change out of the laundromat machines. And so every time they found the small change, they put it in a little piggy bank, and they'd give us that at the end of the month, and it added up to almost $5,000 over a year of small change, and that made a huge difference. So all of us can make a change. If you donate $1, if everyone donated $1, that's $26 million from Australia. So if everyone donated $10, then that's that'd be enough to, I think, find a cure for brain cancer. So please believe me, you can make a difference. And then finally, get involved. And getting involved means where you really identify brain cancer as your charity of choice, or the Charlie Teo Foundation as your charity of choice. And that means putting some effort into not only donating yourself, but getting others to donate as well. I'm not denying that it's hard times. There's financial uncertainty, economic distress. It's not an easy time, but just remember this, that brain cancer hasn't taken a break. People are still dying and suffering from brain cancer, and we can't ignore them. So my hope is that despite the fact that it's economic turmoil at the moment, then people will still realise that these patients with brain cancer really do need some hope, and you're going to give them that hope by getting involved. I'd like to give a big thank you to Little Legs Foundation, and I think they epitomise what a single family can do. So this is a family whose daughter Allegra died of DMG, and rather than simply mourn her death, they thought that they would do something positive from her death. And they started up the Little Legs Foundation. They have raised over $500,000 in a very short period of time. They have gone to fund many of the childhood brain cancer projects that I've identified and talked about during the last session. So a big thank you to that family, and I think, if anything positive can come out of the death of a child, it's the fact that other families will get hope and hopefully cures and treatments from their efforts. You can get involved by getting involved with the Aboriginal Art Auction. Now, what is that? Well, a very good friend of mine, Matt Strawbridge, he introduced me to a chap called Chris Simon. Chris Simon probably has the most authentic, diverse collection of Aboriginal art in the world. He sells art to collectors from all around the world, and he has very generously given, I think, 20 pieces of Aboriginal art to raise money for my foundation. So that's called the Yander Aboriginal Art Centre in Alice Springs, owned by Chris Simon, and I thank him very, very much for getting involved. And you can get involved by buying those pieces of art or bidding for those pieces of art on our website. Okay, and if you really want to get involved, I'm very excited to announce the Brain Freeze Challenge that's being launched today. What is it? Well, we all know what brain freeze is. It's a phenomenon that happens when you eat something cold or drink something very cold. It's not bad for you, and we are asking you to get onto your social media, get a video of you getting a brain freeze, and then to spread it and challenge others to video themselves as well. We're really, really thankful and excited to announce that Cold Rock have come on as one of our sponsors, and as a vegan, they do have a vegan selection. So for those of you who want to get into the challenge, set up your Facebook fundraising page. For vegans or non-vegans, go to your Cold Rock ice cream store, or you can get it delivered, or you can get it takeaway, and start videoing yourself experiencing a brain freeze. So to all those overseas guests listening to this segment, I challenge you as well to spread the word in your own countries to help me put a freeze on brain cancer. So that ends this session. Thank you very much for listening and participating and getting involved. And there's a little bit of a teaser for next week. Many of the questions have been asked about my professional life, what it's like being a neurosurgeon, how I deal with the tragedies and how I deal with my patients. So I'm going to address some of those questions next week. Thank you very much and see you then. Bye.